We'll talk about money and mining later. Absolute value part 2. What is it? Just because Shelby wasn't here. What's absolute value? Will. Well done, Will. Let's all give him a hand. Hey. Absolute value is the absolute value. No, it is difficult to put in words. What's the meaning? All we need to know is it's the distance from 0 on a number line if it's something simple. Okay, one of you guys will be moving if you don't zip it. Okay, graphically, all you need to know is this. It can't be negative. Okay? If you have a graph of some line, what's the absolute value of it? You erase this part, okay? All the negative stuff, and you make it positive. You just flip it up. That's it. Okay? Oop. Gotta go back to my stroke. So, number 9 yesterday, which was, I think it was that. And I went around the room and looked at some people, and I think we plotted some of this stuff in quadratics, but I know that was like, I don't know, 1/6,000th of your life ago, like 3 weeks. Okay? What does this thing look like? It looks like this. Okay? That's a parabola with an origin as a vertex. Okay? Because P is 0. And Q is 0. Okay, we only got what, 2.5 weeks, right? And that's it. We got to start reviewing this stuff, so we may as well start now. Okay, P0, Q0, so it's just x squared. What does this thing do? And I said back then, is it a P or a Q? Is it in the brackets or is it not? You see any brackets here? Okay, that thing looks like this. X minus 0 squared minus 4. Ah, okay, that's definitely a Q now, right? So that does what? That moves it up or down, okay? P moves it left or right. And we know we got this opposite thing happening. If it's minus 3, it's 3 units positive, okay? If it's plus 3, it's 3 units to the left. So anyway, this is x squared minus 4. That's this thing, 4 units down, okay? Just a rough sketch, there it is. I could find the zeros of that. Shouldn't be too hard, but just a rough sketch, that's what's going on. If all I do is make that absolute value, that's my sign for absolute value, what happens? The negative part gets flipped up and becomes positive, okay? That's it. The other positive parts stay as they are. Okay? Absolute value means there's no negatives. All you do is flip it up. Okay? As a piecewise function, this thing has 3 parts. There's this part. There's the part that changed, got flipped up because I can't have any negatives. And then there's this part. All right? The first part and the last part, they didn't change. It's the same thing. The only thing that changed was the negatives became positive. Okay? That's absolute value in 1,000 words or less. So not all of us have this. I'm just going to check it with a graphing calculator, but you could solve that using this. I'll show you how to plug that in a sec. All right. There's another way to do it, the x-intercept way. Okay. You could, well, quickly, you could plot this one and then plot that one and see where they cross, see where they intersect. That's the solution. That's where this thing is equal to that thing. That's one way. The other way is, well, let's just put this thing over to that side, have it equal to 0, plot that function just as it is, and find the 0. Okay? You get the same answer. Both ways. I just want to focus on algebraically, and I'll show you with a graphing calculator how you can check. Okay? So this is the understanding of it. All these steps, but I'm going to hack a couple of them off. Okay, step 1, find the value of the variable which makes the expression within the absolute value symbol equal to 0. You remember yesterday? No. We had this line, okay? X minus 3. 1, 2, 3. Okay, looks something like that. Okay, that's grade 10. Grade 11, absolute value. What happens with that graph? All the negatives flip up and become positive, okay? I don't have this guy anymore. Okay? Graphically, that's all that goes on. Right? But how do I graph this part? If it's positive, okay, if this thing is greater than or equal to 0, it's just the function itself. But if it's negative, I can't have a negative. How do I make that thing positive? By sticking a minus in front of it. Then it becomes plus 3, right? So how do I make this thing positive? By putting a minus in front of it. So for everything where this thing is less than 0, i.e. where this thing is negative, that's how I graph this. And if I graph this just for these values, okay, that's what I get. If I graph this thing just for those values, that's what I get. So the questions yesterday said, how do you graph this without the absolute value stuff? Well, you got to do it in 2 parts. That's why they call it a piecewise function. Okay? And where is this thing 0? That's what this says. Where's this function 0? Right there. Okay? 3. That's step 1. Divide the domain into smaller subdomains using the value found here. Okay, so I got this part, that's a subdomain, and I have this part, that's a subdomain. Okay, I'm just going to go over this, then I'll give you an example. Write the absolute value expressions in piecewise form. That's what I just did. That's what you did yesterday. Okay? Solve, that's the difference now. It's not just graphing this. Okay, we want to solve it. Okay? And then check, combine, see if it's valid. You got to check it to see if it works. So I'm going to do this guy first, and then I'm going to do it again with a different way of thinking about it. Okay? So Haley, solve this equation algebraically. Complete her work. Step 1 said, where's this thing 0? I just want to look at the absolute value thing. You know, if you didn't have the absolute value, it'd be a piece of cake, right? That's the only tricky part now, is like, what do you do with that? Where's this 0? Where x is -3. Okay? Subdomain. We're going to say this, and then we're going to forget about it. All right? For values greater than that, okay, like what's greater than -3? -2. 3 plus -2, this is positive, isn't it? Okay? Anything greater than -3, this thing's going to be positive. Like 0 is greater than -3. 3 plus 0, that's positive. Okay? Everybody okay with that? If this thing is positive, do these lines mean anything? They only mean something if it's negative. So I can get rid of them, right? So if this is positive for values of x greater than or equal to -3, that's all I do. I don't even have to worry about the absolute value part. It only matters if it's negative for values less than -3, i.e. -4. Is that less than -3? Yes, it is. If I put -4 in here, I get 3 minus 4, which is -1. I can't have a negative because that's what absolute value means. It becomes +1. Okay, that value gets flipped up and becomes positive. So how do I make a -1 a positive? What's our little trick? Just put a minus in front of it. Okay? So put a negative in front of the function. That flips everything that was negative to being positive. And then we solve that. Okay? So you just got to do it in 2 parts. That's all. So how do I solve this thing? Okay, well, -x there. That's x. So let's minus 1 there. X is 2. That's one solution. But we got to check it. Okay? This only works if it's in that range. Because this is only for values of x greater than or equal to minus 2. Is 2 greater than or equal to minus 3? I think I just said minus 2. Yeah. Yes, it is. So that's okay. All right? All right, 2 is greater than or equal to minus 3, so that's okay. All right? Let's look at this. That's minus 3 minus x is 2x plus 1. Okay, let's add x to both sides. 3x. Okay, so let's get the numbers over there. Is minus 4. Divide by 3. So x is minus 4/3. Telling me that's a solution. Does that work with my subdomain? This is only working if values of x are less than minus 3. Is negative 4/3 less than minus 3? That is like 1.33 repeat, right? That's not less than minus 3, is it? Right? And if we're really terrible on this, you would do a number line. Okay, that's about here, but I need all values less than this. Okay, that doesn't work. So I have to reject that. Okay, so my only solution is it in the subdomain? No. This one was. That's the only thing I can do. So that's the way the book's kind of laying it out. I'm going to do the exact same question. I'm just going to say less. Okay? Because unfortunately, lots of kids these days, they don't really want to understand what's going on. They just want the answer. Right? They just want the answer, Mr. Watson. What's the shortcut? Right? Just give me the answer. Okay. So, let me repeat that. Here's the strategy the book says, and let's read this. Blah, blah, blah. The method below has the advantage that a virtually identical method can be used to the solution to other absolute value inequalities in calculus, i.e. TRU, and other high-level math courses, i.e. TRU. Okay? But let me revise this a bit. That's the understanding, okay? Absolute value, there's no negatives. But as a piecewise function, okay, let's just look at this guy. Again, if that's positive, do I have to worry about absolute value, Will? No, I don't. So I'm just going to solve that. If it's positive, that's all you have to do, right? That's what you would have got in grade 8. You would have got 2x plus 3 is 8, solve for x. But we just need to worry about the negative thing. If it's negative, we got to flip it and make it positive. How do you do that? Just put a minus in front of the function. We have to solve that one. Okay? And then all we're going to do is, let's just verify it. Okay? Okay, so that's what I just did. Piecewise, well, I haven't done it yet. We're going to do that. Okay? Solve each and then just verify the solution instead of worrying about this subdomain stuff. Okay? So 2x plus 3 minus 3 to both sides. 2x is 5. Okay, this says x is 5 over 2. Let's check it to make sure. Okay? If I put that back in here, okay, the original equation, 2 times x plus 3, does the left side equal the right side? In other words, does this work? 10 over 2 is 5. Is the absolute value of 8 equal to 8? Yeah. Okay, so that one's okay. Let's solve this guy. Okay, add 3 to both sides. Minus 2x is 11. So x is minus 11 seconds. Okay, so far that looks like a solution, but we got to verify it. We got to check it. So plug it back in. I should have wrote check there. Absolute value of 2 times x plus 3. Does that work? Minus 11 plus 3, absolute value. Does that equal to 8, Dannon? Yes. Absolute value of negative 8. Is that equal to 8? Yes. Because negative 8 is 8 units away from 0. 8 is 8. Yes. Okay? So both of these work for this question. Those are your 2 solutions. X is minus 11 over 2 and 5 over 2. Now would be a good time to check. Again, there's 2 ways to do this. I think most of us would go, where's this thing equal to 0? Okay, that's the same as this, right? A minus 8 to both sides. Find the 0. So absolute value, math button, move over to number. See, number 1 says ABS. That's not anti-lock braking system. That's absolute value. The absolute value of 2x plus 3 bracket minus 8 there's the graph. No, don't get confused. I know you're saying there's negatives there. Well, that's because I manipulated this a bit, okay? I put the minus 8 over there. Here I want to find the zeros. Does this look like minus 11 over 2 or minus 5.5? 1, 2, 3, 4, 5. Yes, it does. Does this look like 5 over 2 or about 2.5? Yes, it does. Okay, there's the 2 solutions. So you can check it with that. Now, like I said, I want to do this question again without worrying about the subdomain stuff, just doing it the way I did that one. Okay, here it says an alternative method. I think this is the way you're going to want to do it. Okay, that's the same question. So as the steps go, okay, step 3, write it in piecewise form, just like you did yesterday. Solve it and then check it. Okay? Piecewise form. This guy, if it's positive, I don't have to worry about the absolute value part. Okay? But if it's negative, I just put a minus in front of it. Okay? Solve each one and check the answers. That's it. Okay, so for this guy, I already did this, didn't I? Minus x, I get an x here. Okay, minus 1, I get 2. Let's plug it back in and see if it works. X is 2. 3 plus 2 is 2 times 2 plus 1. Does that work? Is the absolute value of 5 equal to 5? Jake? You bet. Okay? Yes. Okay? So x is 2. There's a valid answer. Now remember, this other one doesn't work, but let's do it again. So minus 3 minus x is 2x plus 1. Let's do it the other way this time. Minus 2x to both sides, so that's minus 3x. Okay, so add 3 to both sides. That's 4. Divide by negative 3. Okay, so x is minus 4/3. Do I know if that's a valid solution yet or not, though? I got to check it. Let's plug it back in. I know everybody loves fractions. 3 plus x, absolute value, is that equal to 2 times minus 4/3 plus 1? Okay? Thirds. In terms of thirds, what is 3? 1 goes into 3 3 times. 3 times 3 is, that's 9/3. Right? That's minus 8/3 plus 1. But I want this in thirds. What's 1 in terms of thirds? 3/3, right? Or, you know, hey, I need that 3 times goes in 3 times 1, that's 3/3. Okay, 9/3 minus 4/3 is 5/3. Absolute value of 5/3 is just 5/3. What's over here? What's minus 8/3 plus 3/3? Minus 5/3. Is 5/3 equal to minus 5/3, Reese? Nope. Okay? Reject. Don't work. So the only answer is x is 2. Okay? So the toughest part being a math teacher is how much do you say? How little do you say? Which way do you show them to do it? Okay, I was going around for like an hour trying to figure out how to say what I said. I think that's the best way to do it. Yep. Well, you're right. We got the same answer. It's very similar, isn't it? Well, this is the difference. Steps 1 and 2 in that flow chart, they say do this. Find out where it's 0. Then look at the subdomain, and you can check your answer against the subdomain to see if it works. Okay? This doesn't fit in your subdomain. That's fine for that question, but I'll just let you know, when you get questions like this, and you start squaring it, and you know when you take the square root of it, you got a plus or a minus, it gets very, very confusing. So you're right, it kind of looks the same, doesn't it? This is the way you should think about doing it, okay? So if you like looking at steps, there it is. Skip step 1 and 2, just do 3, 4, 5. Just check the answer. Check it back in the equation and see if it works. It's, I think, less confusing than trying to check it against the subdomain. All right, so last one. I just want to look at this, because you did have one like this yesterday, and you're going to get some today. Consider that equation. X squared minus 9. Y'all have a mental image of what this looks like? It's x squared down by 9 units. That's it. But if that was the case, if I take the absolute value of it, all the negatives get flipped up. Okay? It's not negative 9. That would be positive 9 now. Okay? So that's what that guy would look like. Okay? This is equal to 7. Where's 7 on this graph? There's 9. 7 is about there. How many solutions are we expecting? How many intersections of those two graphs do we have? 4. Cool. Now let's show you how easy this is algebraically. Piecewise function. If this thing is positive, that's what you have. Okay? So x squared, add 9 to both sides. So x is the square root of 16, but remember, there's two answers here. So x is plus or minus 4. Okay? There's two answers. But what happens if this function was negative, i.e., this part here? I can't do that. I have to take the positive of it. How do I do that? By putting a minus sign in front. Let's solve that guy. Minus x squared plus 9 is 7. Subtract 9 from both sides. Okay, so minus x squared is minus 2. How do I make it positive? Multiply both sides by -1, or put the minus x squared on this side, it becomes positive. Put that on that side, it becomes positive. Okay, divide by -1. There's lots of ways to think about it. What's x? X is plus or minus the square root of 2 as an exact answer. As a decimal, that's like 1.41 something, right? Okay, there's two answers. 4, -4. There's two answers. 1.4 and -1.4. Okay, so not so bad, right? And lastly, how can we check that guy? That is x squared minus what? 9? Oh, I got a bad memory. Okay. Or, okay, I got to bring the 7 to the other side, right? So x squared minus 9 minus 7, where is that thing equal to 0? Does that look like plus or minus 4 and plus or minus 1.41? Sure. I don't know if this is a good idea or not, but let's do it this way too. When do these two graphs intersect? Does that look like the same as my picture? Okay, same thing. There's two ways to graph this. Solutions at 4 and -4 and 1.41 and -1.41. Okay, 4 solutions. Okay. 4 and 5, A to D, not too much, but you guys got a quiz tomorrow on rational equations, okay? Now, if you want some practice questions for the quiz, here's two good ones. Your quiz is just going to be 2 questions, and they're going to look like these. Am I too nice? You think your university professors will do this? All right, do those 2 and you'll be in great shape for the quiz.